Methods of integration. Firstly, there are two types of integrals, definite and indefinite. Definite integrals result with a value. Indefinite integrals result with a function. The different methods of integration I'm going to talk about are U substitution, integration by parts, trig substitutions, partial fractions, derivatives of trig inverse functions, and the trig function's antiderivatives. U substitution is one of the first methods you should try to do when you're integrating. You use U substitution when there is an inner function and the derivative of the inner function is in the original equation. For example, you have the integral of 2 times the square root of 2x plus 1 dx. My first step, I got rid of the radical sign and made it a fraction, as you see here. Since I am doing U substitution, I'm going to make my inner function 2x plus 1 my u, and the derivative of that is 2 dx. After getting my u and du, I plug in my u into the function as I did here. Since 2 dx is equal to du, my 2 dropped and I'm left with u to the 1/2 power du. My next step is to use the power rule, which means you add 1 to the exponent and whatever you receive there is what your denominator will be. And since I do have a fraction underneath the u, I would have to reciprocate it and put it in front of the u, making it 2/3 times u to the 3/2 power. In my final step, I plugged the u back in, giving me my final answer, 2/3 times the quantity of 2x plus 1 raised to the 3/2 power plus c. My next method is integration by parts. Integration by parts is used when you have two functions multiplied by each other. You use integration by parts almost the same way as U substitution, with the formula, the integral of u times dv, which equals uv times the integral of v du. Making the u the inner function and the dv the outer function, you would use Liate to identify the u. Liate means natural log, inverse, algebraic, trig, or exponential. Next, we have trig substitution. Trig substitution is used when you replace the variable of integration by a trig function. In other words, when a radical is raised to an exponent, you use trig substitution. Using trig substitution is almost like using U substitution, except you say a tangent substitution or a sine substitution. After finding x and dx, you go on to solve the radical or the denominator using double angle identities. The double angle identities are sine squared of theta equals 1/2 times the quantity of 1 minus cosine 2 theta. Cosine squared x equals 1/2 times the quantity of 1 plus cosine of 2 theta. Sine of 2x equals 2 times cosine x sine x. Next is partial fractions. Partial fractions is used when you have a quotient of polynomials in the denominator that can be factored out. And to do so, you'd factor out the denominator as much as possible, then break it up into smaller fractions. Lastly, there is trig inverse. Trig inverse functions are used when you see 1 over x squared plus a squared. To use trig inverse, you basically have to memorize the derivatives like you would for any trig function. They are sine to the negative first power times x over a plus c is equal to the integral of 1 over the square root of a squared minus x squared dx. The derivatives for trig functions are sine x equals cosine x equals negative sine x, tangent x equals secant squared x, secant x equals secant times tangent, cosecant x equals negative cosecant times cotangent, and cotangent x equals